My name is Cherubim Fiajibe. Today we'll be looking at Introduction to Computers, the five generations of computers. This is our outline for the presentation. We will look at the introduction, that is the general overview of what computer is. Then we'll look also at the concept of computer generations. Then we'll look at the five generations of computers from the first generation to the fifth generation. Then we'll also look at the comparison table of the five generation of computers. Then we'll look at the summary and we will do some assessment based on what we have learned. Let's dive straight into the presentation. What is a computer? A computer is a programmable electronic device that accepts data as an input, processes the data into information, does storage, and also facilitates communication. Other books also explain computer as an electronic machine that takes in data, processes it, and gives out information. It can store, it can organize, and manage data quickly and accurately. Simply put, we can say computers help us to solve problems and perform tasks with speed. Let's look at the importance of computers in our daily life. Now, computers have become a part of our day-to-day activities. Now, in schools, we use computers for learning, for teaching purposes, for research work. We use it to do our assignment. Anytime we are faced with any task, we go online to research to actually enhance our search of information. In our offices, we use computers for writing or typing our document, sending of emails, and keeping record of all documentations in the office. At the hospitals, the computer basically is used for storing patient records, checking health conditions. There are sophisticated systems now that we'll look at it in the process of the presentation, that now computers are used, robots are used in performing surgical operations. Robots are used, or computers are used, advanced ones, to check systems and make medical processes very, very easy. Then in our homes, we play music, we watch movies. So generally for entertainment, we use our phones for communication. We go online. Those who are engaged in distance learning, they go online to actually have their lectures and all that. We also fetch for information to enhance our process of learning. In our shops and banks, we said we use computers for selling goods and keeping our money safe. So we transact businesses online, and then it has made our lives very, very easy. Now, let's look at the overview of how computers have evolved over time. Now, computers are not the way we see them today. Generally, when it started, it's a whole big system producing a lot of heat, and then as technology evolved, we now have what we have as computers. So let's look at this picture here. So computers were as huge as a whole room. Okay, and now look at what has become of computers. Now let's go on. So you realize that these are the first computers that we have had in the system. We will talk about it. As big as this, and then it has changed so many advanced processes and evolution, and have changed to what we have today as our smartphones, as our laptops, our tablets, and all the portable devices that we can think of. All right. Now, what we are saying is that computers were not always, uh, they were not actually looking like this in the past. Okay, the first computers were very big, they were slow, they were very expensive. Okay, over the years, uh, new technology has made them actually smaller, uh, faster, cheaper, and smarter. Okay, so these changes that occurred along the line, the innovations, the changes in technology, the changes in how computers process data, the changes in the devices along the way to enhance the performance of the computers, to make them cheaper, to make them faster, to actually make them more compact. These different stages is what we refer to as generations. These different stages is what we refer to as generations. So we can talk about each generation having introduced different way which computers can process data. So we can talk about the first generation that introduced vacuum tubes, okay, until when we had when we now have artificial intelligence. So when they were using vacuum tubes, computers were as big as this, very big as this. And then now we have now we have portable devices as laptops, and then tablets, and um, mobile devices like our smartphones. Okay, now let's look at the purpose of studying computer generations. The purpose of studying computer generation. Learning about the five generation of computers helps us to understand how computers have changed over time. So computers started from somewhere, and it will give us a fair idea how the evolution occurred, how changes occurred along the line. Then it will also helps us to appreciate how technology has improved over time, right? And we also know how today's computers came to be, how how we have our mobile devices now, and how they have come to be in today's world. And it will help us to get ready for future changes in computer technology. Very, very important. Now let's look at the concept of computer generation. What does it mean when we say generation? What does it mean when we say generation? In computing, when we say generation, it means the different stages in the development and improvement of computers over time. Okay, how the evolution occurred, how changes occurred over time. So the major things that actually transformed the shape and size and efficiency, the speed of computers from the beginning to what we have now as smart devices. Okay, for example, we can talk about vacuum tubes, while we use transistors in the second generation up to today, where we have the fifth generation, where we use artificial intelligence. We are going to explain these things one after the other so that we appreciate what the generation uh, talks about. So when we talk about generation, we are just talking about the development and improvement over a period of time. Over a period of time. Why are computers grouped into generations? Very, very important. Now, We group them into generations because it helps us to understand how technology has changed. And then it helps us to understand how computers have become smaller, faster, and more powerful. The way we use computers have also changed. Hitherto, we always use computers in a stationary place, but now we can move computers around, carry it along, even in our pocket. We are now having wearable devices and all that. So it helps us to actually know how things have changed over time. Now, one thing that we have to take note of is that each new generation brings better performance, more storage, ease of use, lower cost. Okay, so it helps us to actually group them into those specific historical changes and then the progress that computing is making so far, as much as technological changes are concerned. Now let's look at the key features used to define each generation. There are some key features that are used to define each generation. So one generation is different from the other. What set them apart? What set them apart? So we can talk about technology used. Okay, each generation talks about a specific technology used. We will talk about them one after the other. We'll talk about the vacuum tubes. We'll talk about the transistors, the ICs, the microprocessors, and now we have artificial intelligence. So those are some of the basic changes that have occurred as much as technology use is concerned. Then we'll also talk about the size. We have very large systems, larger systems, smaller, compact, and very compact systems. Then we talk about the speed, the rate at which they perform their task when assigned. We can talk about the very fast up to the very extremely fast devices. Then talk about the cost. Very expensive, then it gets less expensive over time. Then we'll also talk about the efficiency, how accurate the process data, how much heat they produce, the memories that they work with, from better performance, from low performance to better performances. We look at all that. So those are the criteria, those are the features that we use actually to differentiate between each, or that's what we use to define each generation of computers. Right. Let's delve straight into the generations of computers. So basically we have 5 generations of computers. So we'll look at the first one, and it spans from 1940 to 1956. When computers started within this time frame, the technology used is referred to as vacuum tubes. Vacuum tubes. So vacuum tubes were used in the first generation. So vacuum tubes control the flow of electricity and help the computer to work. Okay, and as we can see from here, they look like bulbs, like light bulbs. Okay, so that is the main circuitry of the computer in the first generation. Let's look at some basic characteristics of the first generation. So they are very big in size, very big in size. Some are as big as a whole room, and they produce a lot of heat. When it is in use, and they are very slow, very slow. So these computers can only do a few tasks at a time. And then they are very expensive because it's a novel development. It is very expensive. Only bigger organizations, government institutions, universities that could afford to buy those devices at the time. Now let's look at some basic examples. We have the ENIAC, that is the Electronic Numerical Integrator and Computer. That is the ENIAC, so the first generation of computers. Then we can talk about the UNIVAC, that is the Universal Automatic Computer. Universal Automatic Computer. These are some of the the first real computers used in calculation and data processing at the time. Now, uh, let's take a look at this picture. This is ENIAC computer. This photograph was taken by a US Army photographer. This is an ENIAC computer. And then we also have the UNIVAC. The UNIVAC. These are the first generations. This is the UNIVAC. So they use the vacuum tubes as their circuitry. Let's take note of that very importantly. Some of the basic limitations of the, the first generation is that they are unreliable. So vacuum tubes often broke and then got bent. So they have to be replaced, and it makes the processes very, very cumbersome. And they use a lot of electricity. Use a lot of electricity in order to power them to make the computer work effectively. It produces too much heat. If we can remember the bulbs that we use in the house, similar to that, they produce a lot of heat, a lot of heat. So they need a very good cooling system in order to actually curb the heating, but it costs expensive. It's very, very expensive when it comes to cooling of those systems. Then it was very difficult to use. Only experts could operate them. There are specific people who are trained actually on the use of this first generation, because it's a new thing that has come. Only experts are able to operate them effectively. All right. Now let's look at the second generation. The second generation spanned between 1956 to 1963, and the technology used is transistors. These are the transistors that we have. So from vacuum tubes, we move to transistors, and this is a sample of the machine. Now, the transistors were used instead of the vacuum tubes in the second generation of computers. So transistors are quite smaller as compared with the vacuum tubes, and then it controls the flow of electricity. It is much smaller, cooler, and more efficient than the vacuum tubes. So there has been an improvement in the design and in the technology that is used. So smaller in size. So as compared with the first generation, it is smaller. It is smaller in size as compared with the first generation. The second generation that uses the second generation that actually use transistors worked faster as much as the speed is concerned than the first generation that used vacuum tubes. And then as compared with the first generation, it is more reliable, and then the transistors lasted longer than the vacuum tubes, which breaks easily. Okay, so the transistors become actually last longer than the vacuum tubes comparatively, and it uses less electricity as compared with the first generation. All right. Now let's get some basic examples. We have the IBM 1401, and then we also have the second version of the UNIVAC, that is the UNIVAC 2. So this is the IBM 1401 mainframe computer. This is how we had in the past. And then we also have the UNIVAC 2. This is how it looks like. We use the transistors to control them. That is their processing device. Now, what novel improvements or what significant improvements can we record apart from the change in technology We also have better storage system. Computers could store more data and programs. And then what actually uh, transformed the whole generation is that in the second generation there was an introduction of a new programming language, that is the COBOL, and then the Fortran. Okay, that gives the computer some instruction to perform. We said that computers work under a set of instructions. So the first programming language was introduced, that is the COBOL and then the Fortran, so that it makes computer easier to, to, to give instruction, so that it can work under that instruction more accurately. All right, and more accurate results as compared with the first generation. Computers make fewer mistakes when you compare it with the earlier generation. Okay. Then we also say that transistors help computers become smaller, faster, and more useful. That is where we transited into the third generation, where we have integrated circuit as the technology used. Now, the integrated circuit has actually helped computers to achieve that compactness. That's helped computers to achieve that compactness. Integrated circuits, we call them ICs. ICs. So these ICs is an integration. Okay, it contains small chips, okay, of many transistors put together in a tiny space. So instead of having separated transistors, we now packed all those transistors, designed all those transistors into a smaller space. We call them integrated circuits, like several transistors put together in a different design. And it has made computers look much smaller and more powerful. So it's like packing more power on a smaller space. So computers reached compactness in the beginning from the third generation that spanned from 1964 to 1971. Very, very important. Let's take note of the years 1964 to 1971. The technology used is integrated circuit, and this is how the IC look like. Very powerful. Then we compared to the first generation and the second generation, we said we have achieved that compactness. Computers are now very small to fit on our desk, and then get smaller spaces that we can use them. It became more efficient. More efficient. They work faster. They use less power. They become more affordable. They were cheaper than the earlier computers, and they produce less heat. ICs did not get as hot as vacuum tubes or separate transistors, so they produce less heat. They produce less heat. Now let's look at some basic examples. We have one popular third generation computer was the IBM System 360. We look at the picture. It was used in so many businesses and then schools at the time. Yes, this is how one looks like. It was being used in schools or being used in organizations. Right. Then we have the IBM S360. This is how it looks like. It's a mainframe machine. This is how it looks like. Okay. Then one of the things that we can talk about in the third generation is that these computers were now used for business, used in businesses for data management, accounts, and then printing of reports. So there's a wider use in the society now. People were getting to use it for their personal stuff. They were used in schools, universities for teaching and research purposes. Government also used them in administration and planning of its activities. So now the computers became more common and useful to so many people. And the big step forward that will be a game changer is getting the computers to be used by people to have their personal computers so that they can use it in their homes for their personal gains. Then we talk about the fourth generation of computers, that is from 1971 to today. And the technology leveraged is the microprocessors. Microprocessors. So the microprocessors were introduced after the third generation, that is in 1971. So 1970, 1971, we have our microprocessors, and this became a game changer. And people started to actually have computers in their homes, and computers became very small in size. Now, when we talk about the microprocessor, that is the small chip that contains the central processing unit. Central processing unit consists of the arithmetic logic unit and then the control unit. We will talk about that in another discussion. But as much as the CPU is concerned, that is the brain of the computer, and they are faster and then smaller in space as compared to the previous generations. Let's look at some of the basic characteristics of the fourth generation. The computers very small in size. Computers can now sit on our table, fit into our bags and pockets. Very, very interesting. Very, very interesting. Very, very interesting. Okay. Now they became very fast. Now we have moved from several different types of processors until we have gotten to Intel Pentiums. Now we can talk about processors called i9. We can talk about i3, i5, i7 processors. We can talk about the M1, M2 processors. There are a lot of processors now in the system, and it is making computer processes very, very, very fast. We can process billions of instructions within a split of a second. So computers have become very, very fast, cheaper, and widely available. Now, once we have enough money, from let's say 800 Ghana cedis or less, to how much you can afford any system, any small system that your money can take you, and they are available everywhere. Either to there are specific places that you can go to buy computers, but right now um, computers are made available for the general public, individuals, to be able to get easily. They use less electricity. Yes, computers have become energy efficient and better to use, better for everyday use. You can charge your phone, you can keep your computers on while it is in use. And as compared to the previous generation, you realize that the ecosystem of computers, as much as energy consumption is concerned, it has reduced drastically, and computers have become more energy efficient. Okay, let's look at some basic examples. Yes, so we have desktop computers, which are used in our homes, our offices, our schools, now available everywhere, every corner. Then we have our portable computers for students, for workers, for travelers. Okay, now we have our laptops. We can carry them anywhere that we want to carry them. Then we have our smartphones and our tablets. Smartphones and our tablets. And some of them even process faster than our laptops and our desktop computers. It is very, very interesting. So we have our laptops, our desktop computers. So this is a complete system. Hitherto we have the system unit, monitor, keyboard and mouse, but we have complete systems now that has embedded system unit in the monitor as one device. The Apple devices also have one. This is a MacBook laptop. Very, very nice. Contains a lot of processing power. Then we have our smartphones and then our tablets. So these systems, very powerful, very portable. We can use it to perform a lot of tasks, and it has made communication very effective. People are able to share information easily. Now, hitherto, we need experts to be able to do coding and program the computer to perform specific tasks or function. But now, because of the graphical user interface, where users can click on icons instead of typing command as in the command line interface, people get to actually use computers more effectively with little or no help at all. Operating systems like Mac and Windows have become more popular now. Now we have the Mac operating system, we have the Windows operating system, then we have the Android system, and then we have the sorry, we have the iOS for Apple devices. Then we have Mac operating system for MacBooks, Apple laptops. Then we have the Windows operating system for other machines as well. Okay, so this is the interface of is a graphical user interface for Mac operating system. It is easy and user friendly. You can just click the icons and you are good to go. There is no typing of commands or anything. Then we have the Windows interface. Very, very user friendly. With just a little tuition, anybody at all can use the Windows operating system. Alright, so the fourth generation revolutionized computing by putting powerful computers into the hands of everyday people. Now we have our smartphones packed with a lot of power that we can use at home, we can use in our school, we can use in our work life and any space that we find ourselves. Then we are into the present and the future. Artificial intelligence. So the fifth generation of computers. It goes beyond today. It goes into the future. And the technology leveraged. We can talk about artificial intelligence, we can talk about robotics, and we can talk about machine learning. Machine learning. Now, the fifth generation of computers is based on artificial intelligence. That tells us that computers now are designed to think, to learn, and to make decisions, just like humans do. So, humans, when you are walking and you meet an obstacle, you have to turn a direction. Computers are designed now to be able to think, okay, and rethink their actions. Okay, we have robots, machines that can move and work. We have machine learning where computers get better, and the more they learn, computers become very adaptive. When they are used in a particular environment, they learn the environment and adapt. That is machine learning. So if I use an application for a long time at a specific time, the computer actually learns how I use it and then adapt to the way I use it. One day I woke up in the morning and my phone asked me if I want to open my Bible app, because when I touch my phone, the first thing in the morning when I wake up is that I want to actually read my Bible before I get to do any other thing that I want to do. So it has studied the way I use it for a long time, and then it has adapted. We call it machine learning. Machine learning. Now we use robots in several places. We'll talk about them one after the other. So the fifth generation of computers actually are very smart. Computers can understand speech. Computers can interpret images. Computers can analyze data. That is the artificial intelligence, the present and beyond. Computers can now appreciate even normal speech. They can perceive their surroundings. They can analyze pictures, and they can interpret or analyze data for us and give us interpretation of those data. Now, in this fifth generation, computers can learn and improve. That is machine learning. They don't need to be told every step of the way. I asked my device what my name is, and then it mentioned my name in a certain way, and I corrected it, and since then it picked the correction and always pronounces the right name for me. All right, so computers can now make decisions. They choose the best route in or answering a particular question. So if I ask my computer a particular question, I have an Alexa which I'm going to use to demonstrate right now so that we appreciate it. When you are using a Google map, it's able to give you a direction, and it makes the best decision of cutting corners and using the fastest route that you should be able to have access to. And then they are smaller and more powerful even than before. Okay, computers have become very small in size. They fit in our pockets. We are wearing them. We have the wearable glasses. We have the wristbands. We have clips that are a whole camera or a computer on their own that people can use to do so many powerful things. So we can talk about Siri and Google Assistants. So I have a phone in my hand here. Hey Siri, what is the time? And it displays the time for me. Okay, then we have the Google Assistants. We can talk about Alexa for Amazon devices. Alexa, what is the time? Alexa, what is the time?
The time is 2:37 a.m.
So you can communicate with these devices in the space that you find. You ask them questions just by voice prompt, and they are able to answer. So let's try with this device and see how the communication is going to go. Alexa, what is a computer?
According to an Alexa Answers contributor, a computer is a machine or device that performs processes, calculations, and operations based on instructions provided by a software or hardware program. It has the ability to accept data, input, process it, and then produce outputs.
So that is a submission from Alexa. I can tell it to actually set alarm for me. Once I give the
I'm not
voice
quite sure
prompt,
how to help you with that.
sorry. So immediately I mention its name. There is a voice prompt that when I mention, it alerts itself and then listen to what I want to say. Alexa, what is my name?
I think you're Cherubim. This is Cherubim's account.
So that's it. It works. Any question at all that it's able to process it significantly. What is Alexa? What is today's date?
It's Monday, August 4th.
So any basic question that you ask, it is able to actually respond to it. Alexa, who is the president of United States of America?
The current president of the United States is Donald Trump.
Alexa, who is the president of Japan?
Japan does not have a president, but the current prime minister of Japan is Shigeru Ishiba.
So you don't have to know everything in your head when you have these devices there. It says that Japan doesn't have a president; they have a prime minister, and it mentions the name. So that is how some of these devices work. It's very very interesting. Then we have self-driving cars. Self-driving cars, because of the way they are able to perceive objects around. I believe that in the future we will not have cars crashing with each other, except for when people start hacking into uh, other people's software. Other than that, cars should be able to communicate with each other and be able to see obstacles and stop. They are able to perceive their surrounding and be able to activate their senses, and I think it will go a long way to protect humanity. Then we have chat boxes. We can talk about programs that are online, that they help facilities that we seek online, how to do this, how to do that, and then we chat and we give prompts and it's able to actually give us answers. We can talk about the artificial intelligence systems that are built, the chat boxes, like um, the ones that generate text for us, the chat GPT, Jenny AI, and all other co-pilots and all other AI systems that generate um, some literature for us when we ask questions. Then we talk about robots. Robots are used in hospitals, factories, homes. I heard about Amazon. Amazon have laid off most of its casual workers because robots are now packing and helping to package things, and it cut down costs for so many institutions. So this is um, Siri, this is Google Assistant, and these are some of the basic chatbots that we use. This is a hospital, and then this robot is actually monitoring the old lady at any point of eventuality. It's able to inform the systems around to be able to guard against anything untoward. Okay, so this is a warehouse. They are able to pack objects according to the addressing systems. Uh, where human errors occur, these machines, these robots are very specific. Once they scan the address, they know exactly where the packages should be and all that. And it is very efficient. It's very, very efficient. And in complex scientific analysis, where hazardous environment where people are not able to work in, uh, robots are able to be programmed to work in those environments. Then, where we have difficult tasks processing computer systems and making things work, these robots are empowered with several processing and engineering codes that help them to be able to process and simulate activities until they get the best solution in uh, any in any circumstance that they find it. There are some problems that we want to solve, but because of the limitations we have as humans, we are not able to process some quantum information. But artificial intelligence systems are now able to do this analysis, do simulations, and process stuff within splits of a second. They are able to come out with some solutions, things that it, it might take our time years to finish calculating. It will take them split of a second to be able to calculate these things effectively. The focus of this generation, that is the fifth generation, is understanding human language. The computer is now created to understand human language instead of coding and pointing and all that. They are able to understand human language. The computers can speak back to us, as are demonstrated with the device here, and then they are able to even translate. I was chatting with somebody in France in French because I was using a chat box that was able to translate my English into French, and I'm able to actually communicate effectively with the person. So computers now understand humans and are able to communicate with humans. When I use these devices in the house and people come around me, they feel like, that means you are living in a house with an artificial intelligence system. I can ask it to set alarm for me. I can ask it to make a to-do list. I'll make a to-do list for it to remind me to make a call at a specific time, to go to a specific place and all that, and it is able to actually remind me. Now, there are several sicknesses that we use prime models to actually find vaccines and find medicines to particular diseases, but it takes time. But with the advent of artificial intelligence systems, now learning has become more effective because the AI system actually help in medicine, science, and education, and things are becoming more effective and more interesting. With the speed of these systems, we are able to actually become more efficient in doing things. Smart systems. Now people can be at work and turn on lights in their homes. People can be at home and monitor things at work and all that. We have smart cities, we have smart schools where the teacher will not have to write on the board anymore. In the absence of the teacher, there are systems in the school that the children can actually go through archives and see the things that has been taught over the period and be able to actually have access to all those things. Now, let's look at the brief summary of what all that we have discussed. We have discussed from the first generation of computers to the fifth generation, that is from 1940 to now and beyond. And each of the generations come with some unique development. And we started from vacuum tubes to artificial intelligence. We talk about very large systems to very compact systems. We talk about very slow systems to now smart and decision-making devices. Okay, and it goes on and on and on. We can just so this is the brief summary of all that we have discussed from the first generation to the the fifth generation. Now, looking into the future, looking ahead, the future of computing holds limitless possibilities with advancement in areas like quantum computing, artificial intelligence, and biocomputing shaping our world. Embracing innovation while addressing challenges will define the trajectory of computing in the years to come. So things are going to be very, very interesting um, in the years to come. The most important thing is that we abreast ourselves with these systems, learn very hard so that we can actually be able to match up with these developments. Thank you very much. I have an assessment for all learners, so we can actually access this assessment. We can click on this button or scan this code to actually have access to the assessment. Thank you very much, and see you again in the next presentation. Thank you.